Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the concepts of Verilog HDL, that is basic concepts and identifiers. So first, what do you mean by Verilog? So Verilog means that is verifying the logic. HDL means hardware description language. So we need to describe the hardware. We are using this hardware description language like C, C++. So here we are going to discuss about the outline. So introduction, and next the programming language versus Verilog HDL, and the design abstraction level, and ASIC design flow. Next the overview about the Verilog HDL module, and next following the activity we will discuss about the identifiers and Verilog HDL structural language and data flow, and next switch level modeling. So these are all the different modeling styles are available, and following into the example programs we will summarize. So first, introduction. So the brief history we have deals with the Verilog HDL. 1985 it started. 1989 the Cadence, the design system that's purchased from the Gateway Automation. 1990 it's open, that is international formed. Verilog HDL International formed, and 1995 IEEE standard 1364 is adopted. So first, the Verilog HDL, already we discussed. Verilog HDL means verifying the logic. It is a programming language used to describe the functionality and the timing of the hardware. That is Verilog HDL. Next, the programming language means we are using this if loop or for loop, and again it is going with the compiler, and again the compiler is going to the assembler. Okay, that is called the programming language. But here the Verilog HDL, we are making the program, that is HDL code, and again the HDL code it is used into converted into the synthesizer. Again based on the synthesizer, the code is converted into based on the design level circuit. So that is the Verilog HDL comparison with the programming language. And next, the different abstraction levels we are using behavioral, RTL, and the switch level. So these are all the different levels we are using for the abstractions. So first we will discuss about the different levels. So first the architectural behavioral level. Behavioral level means it's like a loop format. It denotes the behavior of the circuit. And next the register transfer level, how the design is transferred, that is designed. How your design is having the data, based on the data it's structured. That is RTL level, register transfer level. Next structural level. Structural level means it means that gate level simulation. First we denoted the gate and following with the output, next input. So that is the interconnection between the gates. And this is the three levels of Verilog HDL. One is gate level. So look at this XOR. XOR is the gate. U0 is the keyword or label. Next dot Z, that is Z, denotes the output. HS means half subtracted, that is HS. And again dot A1 is the keyword for the input A, and A2 is the keyword for input B. So XOR means U1 is the keyword, that is the label for U1 is the label for XOR, and next Z is the sum. So sum is equal to A XOR B XOR Cin. Then same thing, you just go for switch level. We are using this only the PMOS and NMOS combinations, VDD, and NAND means that is the output NAND gate, and A is the input, one input, and another thing B is the another input. So same like for NMOS and PMOS. Behavioral level means you are behaving the RTL level. So assign is a keyword used to assign the output C0 and sum. So these are all the different simulators we are using. VCS simulator and Synapsys, Mentor Graphics, Cadence, and the other simulators we are using the Aldex, CIDO. So these are all the different keywords. So first the overview about the Verilog HDL module. We will define module name. For example, you are denoting the module is the keyword. So red color mentioned is the keyword. Module name means anything it may be, like your name or other name also. Port name means that is the input output port name. Next to port declaration, data type declaration, function or task verification, and module functionality and timing specification. Next we finish the module with the end module keyword. Next, the following with the activity, we will discuss about the another thing, that is identifiers. Identifiers means user provided name. This is used within a description. A to Z, small a to Z, capital A to Z, 0 to 9, and special character. So it must start with the character, that is identifier. So for example, these are the identifier. We will discuss about ABC 1 2 3 or capital ABC 1 2 3. And next, the escaped identifier, we use the backslash. So backslash means they can contain any printable ASCII character. So backslash it is used for the escaped identifiers with the white space. So these are the case sensitivity language. So Verilog HDL is the case sensitivity language. So we needed to write the code very carefully. And next, the Verilog module. We are using the module like basic building blocks in the hierarchy level. Inputs and outputs, everything is denoted. The module ports, that is input, output, and in-out. In-out means nothing but bidirectional port. We are using the bidirectional, both input and both output. And next, the syntax of Verilog like C language. It starts with the begin, end if, or for else loop, or backslash, or anything it may be. And the adder, so just to look at this adder with the example, a full adder. So just to compare with the full adder, module, adder is a module name. So module name. Next we find the port declaration, carry, sum. These are all the output ports. A, B, C is the input ports. Output, that is carry, comma, sum. Again the port declaration, input, output, port declaration, or pin declaration. Input means that is A, comma, B, comma, C in. Wire means W0, W1, W2, and XOR, that is the output, that is XOR gate. So it is a gate instantiation. So U0 is the gate label. Sum is the keyword, that is for output, that is XOR output. So sum is equal to A XOR B XOR C in. That is the first line denotes. Same like AND gate means W0 is the wire. So wire means in between the two different gate logic, we are using the wire as a keyword. So W0 and W1, W2, that is same thing we are using. So look at the picture, that is the circuit diagram. Inside the circuit diagram between the AND gate and with the OR gate, we are using the W0, W1, W2. And again the OR gate denotes the carry. So W0, W1 is W2 is the OR gate. So W0 plus W1 plus W2, that is nothing but AB plus BC in A plus C in A. That is called carry. Okay, so carry. Next, everything is okay. So input, output, everything is defined. So whatever the inputs and outputs you defined in the declaration part, everything must be defined in the that declaration, that is definition part, that is the architecture level. So next to the full adder, that is the same thing, we are using the full adder for combinations. So there are different types of combinations we are using, always as a keyword, always A or B or C in, that is also we can use. And the carry sum, that is A plus B plus C in, we are using for behavioral modeling. And for the another gate level modeling, we are instantiated the gate first. And next right side you look at this assign is a keyword, that is for the different behavioral logic level. So you can use the behavioral means that is for loop, always as a keyword. And the gate level means first you are instantiating the gate, and next you are normal. RTL level means that is the assign is a keyword. So next the abbreviations for the Verilog HDL, what are the abbreviation? So next we are going for assessment level. So first the Verilog HDL abbreviation means verifying the logic HDL. Next to the simulators, we are using more simulator, NHT simulator, or I simulator, or Synapses simulator, anything it may be, you can use it based on the Xilinx protocol. And next to the design abstraction level, we are using the abstraction levels for different levels. First the IO declarations and the definition part we are using, and different modeling style, data flow modeling, RTL modeling, and behavioral modeling, and structural modeling like gate level modeling. And next to the Verilog HDL syntax means already I told module name, input output port declaration, and the input output port declaration individually, and following with the architecture part we are defining the different abstraction level, that is for modeling style. And next Verilog HDL code, you can use it for the three different modeling style for the mixed level modeling. So normally the modeling style having three different modeling. One is data flow, architecture, that is RTL, and next to the gate level. So combination of these three, that is called the mixed modeling style. So this is all the assessment. So these are the summary. We discuss about the Verilog HDL languages, verifying the logic. HDL means hardware description language, and we will discuss about the basic concepts and basic syntax about the Verilog HDL and the identifiers. And following with the identifiers, we discussed in the programs for different modeling style using the very full ladder. Okay, so thank you all.